Hello, good afternoon, everyone. I'm delighted to welcome you to another DataZen Greece event, where we embark on a journey to unravel the capabilities and intricacies of two powerful components within the Azure data ecosystem. Today, our focus will be on Azure Functions and Azure Durable Functions, two key players in the serverless computing landscape. In the dynamic realm of data cloud computing, making informed decisions about the services we leverage is paramount. Azure Microsoft's cloud platform provides a rich tapestry of services designed to meet a myriad of needs. Azure Functions and Azure Durable Functions stand out as exemplars of several computing, offering flexibility, scalability, and efficiency. As we delve in the comparative analysis of these two Azure offerings, our goal is to provide you with a comprehensive understanding of their respective strengths, use cases, and how they can help you harness your projects to new heights. Whether you're a seasoned Azure enthusiast or exploring the possibilities for the first time, this presentation aims to equip you with insights needed to make informed decisions for your data cloud endeavors. Throughout our exploration, we will uncover the foundational aspects of Azure Functions, examining the capabilities and real-world applications. We'll then extend our gaze to Azure Durable Functions, exploring how they build upon the foundation of Azure Functions, introducing orchestration capabilities and new dimension of functionality. So buckle up as we traverse the landscape of serverless computing, comparing the characteristics of Azure Functions and Azure Durable Functions. By the end of our journey, we'll have a clear understanding of where to deploy each, optimizing our use of Azure resources, empowering our project for success. So thank you for joining to this exploration of power of data within Azure. And let me now introduce our presenter for today, Konstantinos Iliadis, who is carrying 2 decades of experience focusing on data engineering and has a really strong technical background, having worked for large projects both in Europe and the US. Let's dive in. Konstantinos, the floor is yours.
Yes. Hello everyone. Let me introduce myself. Thank you also for the introduction that I had from Apostolos. So regarding my previous experience, I would like to show you the next slide. So it is both an honor and a pleasure to stand before you today, and as we embarked on a journey into this fascinating world of data science. Actually, in an era defined by information, the role of data scientists has become paramount, shaping the way organizations derive insights, make decisions, and navigate the complex landscape of data. So allow me to introduce myself. I have accumulated over 20 years of work experience, and I possess extensive expertise in various aspects of data management, encompassing data analysis, data integration, data warehousing, ETL processes, software development, and a range of tools and technologies. These include Power BI, DAX, Azure, Data Factory, Snowflake, Azure Functions in Python, data cleansing, SQL, etc. My knowledge extends also to ERP and API development, and I have a strong aptitude for application integration. So, in the realm of serverless computing, Azure Durable Functions, the main point and the main topic that we would like to discuss, stands out as an extension that empowers developers to seamlessly orchestrate long-running and stateful workflows. By leveraging the power of Azure Functions, Durable Functions eliminates the complexities associated with managing state, checkpoints, and restarts, allowing developers to focus on crafting business logic rather than infrastructure. So let's move on with what the topic has to cover. Have you encountered limitations with Azure Functions before? So that means that we don't have to worry, as Azure Durable Functions come equipped with new components that can address and even exceed these limitations. During this event, you will discover how Durable Functions can simplify building complex stateful workflows and orchestrations. Explore how Durable Functions allows you to manage the execution state, handle long-running tasks, and easily coordinate parallel or sequential operations within your serverless applications, unlike traditional Azure functions. So review all benefits of durable functions, including a higher level of abstraction for building scalable and resilient serverless workflows, making it a more suitable choice when you need to handle complex, stateful, or orchestrated processes in your Azure-based applications. We'll cover over the subjects outlined in this slide that presents the agenda for our presentation. So here we have the agenda that covers serverless overview, the Azure functions and durable functions. And also we have the Azure functions resource triggers, what are durable functions common workflows, durable functions types, and practical experience with Azure durable functions. Let's talk a little bit about serverless overview. Azure Serverless is a cloud computing paradigm in Microsoft Azure that allows you to build and run applications without managing the underlying infrastructure. It's designed to help you focus on your code and business logic rather than the server resources. Azure Serverless is a cloud. Let's explain first of all what is Azure Serverless. Is a cloud computing paradigm in Microsoft Azure that allows you to build and run applications without managing the underlying infrastructure. It's designed to help you focus on your code and business logic rather than the server resources. Here's an overview also of Azure Functions and a comparison with the durable functions. Azure Functions, event-driven serverless compute platform for executing code in response to events or triggers, and durable functions is an extension of Azure Functions for building stateful and orchestrating workflows. The Azure Functions, actually, they're event-driven, as we said, serverless compute units that execute code, can be triggered with, let's say, such as HTTP requests, timers, or data changes in Azure services. You pay only for the execution time, making it a cost-effective choice. So the durable functions, as we mentioned before, is an extension of Azure Functions that allows you to build stateful and orchestrating workflows. It simplifies the coordination of multiple functions and provides features for long-running processes, making it suitable for complex event-driven scenarios. Azure App Services. So we will move on with few of the serverless services, actually, like Azure App Service, which is a platform for hosting web application and API with built-in scaling and management feature. The AKS, which is Azure Kubernetes Service, the container apps. So I want to explain all of them since you're going to have also the PowerPoint file, but we can move on with more details about Azure Functions and durable functions. So we mentioned that Azure Functions and durable functions are part of Microsoft Azure serverless computing platform, which allow developers to build and deploy event-driven, scalable, and cost-effective applications without the need to manage infrastructure. So we'll move on with a comparison and the key features between the Azure Functions and the Azure durable functions. The Azure Functions, we have an event-driven triggers. Azure Functions can be triggered, as we mentioned, by various events. It's simple and concise because functions are small, self-contained pieces of code written in your preferred programming language, such as C#, Python, or even JavaScript. Stateless execution, its function execution is independent and stateless, making it easy to scale and manage. Now, coming to Azure durable functions, we see that we have workflow orchestration. The durable functions allows you to define workflows as code coordinate the execution of multiple functions with support for complex control flow and error handling. Stateful execution, durable functions maintain the state of the workflow, enabling you to pause, resume, and retry workflows when necessary. Human interaction, durable functions facilitate human interaction scenarios by enabling tasks to be completed by external participants through approval steps, email notifications, or user interactions. Let's now move on when we're going to use and how we're going to use the Azure functions and Azure durable functions. During the next slides, we will see how we're going to use, but now we're going to see when to use. When to use Azure functions when you need to quickly respond to events, such as processing incoming messages or triggering lightweight workflows. Your application has small self-contained units of code that can be executed independently. You want to leverage a serverless model for cost optimization, as Azure functions scale automatically based on demand. And for Azure durable functions, when to use, you need to coordinate the execution of multiple functions and manage complex control flow and error handling. Your application requires stateful execution and the ability to pause, resume, or retry workflows. Human interaction, such as approvals or notifications, is an integral part of your application's workflow. Now, how are you going to choose the right tool? Choosing between Azure Functions and Azure Durable Functions hinges on the application's specific demands. If you're aiming for a nimble, event-driven setup for swift responses, Azure Functions is the way forward. On the flip side, if your application entails integrate workflows, prolonged processes, and mandates stateful execution, Azure Durable Functions offer the required side functionalities. It's important to highlight that Azure Functions and Azure Durable Functions aren't mutually exclusive. They can seamlessly collaborate within a single application, with Azure Durable Functions orchestrating the execution of Azure Functions when they need arise. In summary, Azure Functions and Azure Durable Functions are potent tools tailored for distinct scenarios. By grasping their strengths and capabilities, you can make an educated choice regarding which framework aligns best with your application's requirements, resulting in scalable, event-driven, and efficient serverless solutions on the Azure platform. So the Azure Functions overview. This section is mostly to refresh your memory regarding the Azure Functions, or in case somebody has not the experience with Azure Functions, so it's good to make a kind of an overview. As we mentioned before, Azure Functions is a serverless compute service provided by Microsoft Azure that enables you to run event-driven code without having to manage the underlying infrastructure. So, what is Azure Functions in an overview? Serverless compute. Azure Functions abstracts away the need to manage servers, allowing you to focus solely on your code and the functions that you want to execute. You don't need to worry about provisioning, scaling, or maintaining the infrastructure. Event-driven, Azure Functions are designed to respond to various events or triggers. These triggers can include HTTP requests, database changes. On that, I can say regarding database changes, when you have, for instance, a new blob placed on data lake, for instance, can be triggered on that, messages in queues, timers, and more. You can define which events triggers your functions, making them well suited for event-driven scenarios. Now, coming to the pricing, Azure Functions follows a consumption-based pricing model. You are billed only for the compute resources used during the execution of your functions. This can result in cost savings as you don't pay for idle time. Multi-language support. You can write Azure Functions, as we already mentioned, in a variety of programming languages, including C#, JavaScript, Python, PowerShell, and more. This allows you to choose the language that best suits you for your application. Now, regarding integration with Azure services, Azure Functions seamlessly integrate with other Azure services such as Azure Storage, Azure Logic Apps, Azure Event Grid, and more, making it easy to build complex serverless workflows. Stateless by default, functions are designed to be stateless, meaning they don't maintain state between executions. However, you can use Azure Durable Functions to build stateful workflows. We will see that in the next, let's say, slides. Automating scaling. Azure Functions automatically scales to accommodate increased workloads. This ensures that your functions can handle varying levels of demand without manual intervention. Development tools. Azure Functions can be developed and deployed using a variety of tools, including the Azure Portal, Visual Studio, Visual Studio Code, and the Azure CLI. You can also use Azure DevOps for CI/CD pipelines. Monitoring and logging. Azure Functions provide built-in monitoring and logging capabilities, allowing you to track the execution of your functions and troubleshoot issues easily. Security. You can secure your functions using Azure Activity Directory, API keys, and other authentication and authorization methods. Functions can also be placed within a virtual network for additional security. Extensions. Azure Functions support extensions, which are reusable components that provide additional capabilities, such as handling external dependencies, sending email notifications, and more. In local development, you can develop and test your functions locally before deploying them to Azure, making it easier to iterate and debug. This is actually doable, and we will see that in the next slides, what tools we need in order to implement the local development. Azure Functions triggers. We mentioned about the Azure Function triggers, so it's good to know that Azure Functions is a serverless compute service provided by Microsoft Azure, and we do have event-driven code which without having to manage the underlying infrastructure. So we're going to go through all these Azure Function triggers, and these Azure Function triggers actually can be also utilized by durable functions. Azure Functions support a variety of triggers, which are events or inputs that initiate the execution of your serverless function. Here are some key details about common Azure Function triggers. We do have the HTTP trigger, an HTTP request, an HTTP, for instance, post, get, or webhook triggers the function. You can define routes and route parameters to customize the URL structure. This kind of trigger is suitable for building web APIs, microservices, and handling HTTP-based events. The blob trigger, something that we already mentioned that also, is monitoring Azure Blob Storage containers for new or modified blobs. Executes the function when the blob is added or changed in the specific container. Useful for processing files, images, and data in Azure Blob Storage. Queue trigger listens to Azure Queue Storage or Azure Service Bus queues for new messages. Triggers the function when a new message is added to the queue. Great for building event-driven processing of messages and task queues. Time trigger executes the function on a defined schedule, like a cron job, useful for running periodic tasks, data cleanup, or background jobs. Event grid trigger listens to Azure Event Grid events generated by various Azure services. The function is triggered when specific events occur, allowing for real-time event-driven processing. Service Bus trigger listens to Azure Service Bus topics or subscriptions for new messages, executes the function when a new message is published to the topic or subscription, ideal for building scalable event processing systems. Cosmos DB trigger, I won't go to all this now, but since you're going to have the PowerPoint, you can read that. IoT Hub trigger, Signals IR service trigger, and Kafka trigger, anomaly detector trigger, custom input bindings, So this is pretty much the triggers. In serverless, here's the main point. What are Azure durable functions? Now we came to the main point, main topic, which is to explain that in a serverless architecture, developers have the ability to create transient stateless functions with a single specific responsibility. Azure functions excel in this context. While this approach has its merits, it also comes with certain limitations. We're going to discuss about the limitations in the next slides. But what happens when we encounter a complex, long-running, or stateful workflow? This is where durable functions step in. Consider a scenario, for instance, where you need to implement a workflow involving 3 Azure functions. Each function performs a specific task, and you must execute these functions sequentially with the output of one function serving as the input for the next. It is possible to accomplish this with Azure Functions alone, utilizing service bus queues to store the intermediate state. Function 1 will place the message in a queue. Function 2 will be a queue-triggered function responsible for retrieving, processing, and forwarding this message to another queue, for which function 3 will pick it up, and so on. However, several challenges emerge when attempting to implement these workflows solely with Azure Functions. Despite the simplicity of the workflow, you're burdened with managing the intricate details of the queues, which can become somewhat cumbersome. Additionally, there is no built-in visualization to depict the relationships between your functions and queues. This issue becomes more pronounced when dealing with longer chains or more intricate workflows where one function's execution relies on another. Lastly, error handling introduces complexity to your workflow. For instance, what happens if function F2 encounters an error? This can result in a partially updated and inconsistent state, potentially leading to incorrect final results. Now, what the durable functions can do? Durable functions are designed to address these issues. They offer a robust and flexible solution for constructing intricate, long-running workflows in the cloud, effectively abstracting away many of the underlying infrastructure and management concerns. With durable functions, you create orchestrations that encapsulate higher-level workflow logic, defining the sequence of activities and the data flow between them. Durable functions eliminate the need for intermediate state management as they handle storage and monitoring workflow process behind the scenes. In orchestrators, where we're going to explain with orchestrators also and all the types of the durable functions, you have a centralized location for defining your entire workflow, simplifying the visualization of relationships between all your functions. Additionally, durable functions offer centralized error handling. When an error occurs within an activity function, the error is propagated back to the orchestrator, allowing you to implement logic to restore the state or take corrective actions. Let me move on now to durable functions common workflows. We're going to discuss about the 5 prevalent workflow patterns that are particularly well suited for implementation using durable functions. So we do have 5 patterns. The chaining workflow, where we have discussed it a little bit earlier, that can be also implemented by Azure Functions and queues. This is the Azure Durable Functions common workflow, the chaining workflow. So, give me a second. The first is the function chaining workflow, where the output of one function is sequentially passed as input to another function. This workflow is invaluable for constructing multi-step processes as it ensures that the output of one step is ready readily available for the subsequent step. For instance, you can create a workflow that takes an image as an input, applies multiple transformations to it through separate functions, and then stores the resulting data in a database. The second commonly implemented workflow with durable functions is the fan out, fan in. So in this approach, a single function triggers multiple functions to run in parallel. After all the parallel functions complete their tasks, the workflow proceeds with a converging step that aggregates the results. This pattern is ideal for concurrently executing independent tasks such as batch data processing. Next, there is a human interaction workflow, which leverages durable functions to construct workflows involving human interactions, such as approval processes. This workflow begins with a request for approval that triggers a durable function. The function can then pause and wait human input, such as a manager's approval of an expense report. Once the input is received, the function continues with the subsequent steps in the workflow. Azure Durable Functions common workflows. The fourth pattern is the monitor workflow, where durable functions are employed to oversee and coordinate long-running jobs. For example, you might have a workflow that pauses until specific conditions are met, such as reaching a predefined threshold or waiting for an external event. We mentioned about our orchestrator, so it's now time to explore a little bit more the types of the Azure Durable Functions. There are 5 prevalent workflow patterns that are particularly well suited for implementations using durable functions, but also we do have these types. So we have Azure, the client function. Client functions are used to interact with durable functions from external clients. They also allow external systems or applications to initiate and monitor workflow executions, query their status, and even make custom inputs to orchestration. Durable client functions themselves can be triggered using standard Azure function triggers, something that we already mentioned, and we also presented the Azure function triggers. That's why we actually focused also for the Azure functions triggers, because as we mentioned, durable functions utilize also the Azure function triggers. So the orchestrator function, something that I would like to go back to the previous one, the client function also, we call it starter somehow. So you may find this term, the client function, as a starter also. Orchestrator function. An orchestrator function in durable functions is a specialized function responsible for controlling the workflow logic, coordinating the execution of other functions, and managing the workflow state. Orchestrators call other functions in a specific order, handle errors, and manage retracing, all within a single cohesive unit. When orchestrators run, they pause when calling other functions, storing the state to resume execution for that point when the child process returns. The activity functions are where the actual work within the workflows occurs. These functions perform specific tasks and return results to the orchestrator. They can perform operations such as database queries, email sending, or calculations. Activity functions are similar to regular Azure functions, but are triggered from orchestrators using activity triggers. It's essential to keep activity functions simple and fast, ideally completing within a few seconds and not extending 5 minutes. And finally, we have the entity functions. Entity functions introduced in the latest version of durable functions and are designed to maintain the state of entities of objects and allow updates to their state over time. They provide an easy way to store data without the need for a database, making them suitable for small states like game scores or counters. Entity functions can be called from orchestrator functions and durable client functions. Here we have also the final type of durable functions that we have covered. Durable entities become, I just have to mention, another type of function, including in Durable Functions 2.0 by Microsoft. Until now, we've discovered how durable functions control and manage workflow orchestrator state using Azure Storage Account, leveraging Azure Event sourcing as part of the control flow. Unlike orchestrator functions, entity functions explicitly manage the state of an entity. In other words, entity functions enable users to create their customized stateful objects and deliver a dependable mechanism for reading and updating state objects. If you require a small state to be saved rather than developing and managing a complete database, durable entities are the ideal options. For example, if your function needs to retain a user's game scores or an attendee counter, durable entities persist in Azure storage and can be accessed by numerous instances of a durable function. Durable entities have an upper hand over managing your own data as concurrency is managed automatically. Instead of storing the entity in a database, it's processed using operations that ensures only a single operation is executed for a particular entity at a specific time, eliminating the risk of race conditions. By default, the durable entity instances reside in an Azure Storage account, which the durable entity function manage. Durable entities can be accessed in three ways: read entity, signaling an entity, and calling an entity that involves round-trip communication. Durable entities may be accessed from the durable client function or the orchestrator function. Examining via the orchestrator function facilitates all three access types, but the client function permits only reading or signaling of the entity without enabling the calling of any entity. So let me give you a summary of the durable functions and the types. Invoke the durable function orchestrator. Monitor status of the durable instance using status query. Client functions trigger using regular function triggers. Orchestrator, the activity, and the entity. I won't explore all of them, but as I mentioned before, you can have the PowerPoint file so you can read the next of the topics. Practical experience with Azure durable functions will provide a comprehensive understanding of their implementation. So based on that, I would like first of all to make a timeline of what we have done so far. So the concept of durable functions is first introduced at the Microsoft Build Conference in 2016. In 2017, Durable Functions is released as part of Azure Functions version 2. 2018, Durable Functions is updated to support external logs, custom durable timers, and improved performance, and etc. For the sake of saving some time of this presentation, I will leave the rest for you to read them because it's all in the PowerPoint slide. Practical experience with Azure Functions. So for local development of durable functions in Azure, you will need Azure Functions and Azure Functions core tools on your local machine. While it's possible to develop using the command line, I highly recommend using a code editor like Visual Studio Code. Visual Studio Code offers a wide array of extensions for seamless integration with various Azure services. To get started, the next step is to install Visual Studio Code. You can download Visual Studio Code from the official website corresponding to your operating system. Once Visual Studio Code is installed, you can open the extension tab and search for the Azure Functions extension. Visual Studio Code boasts an extensive library of extensions that enhance the coding and testing experience, and the Azure Functions extension is the official one provided by Microsoft. So you can install this extension and you will notice a new tab with an Azure icon in the left navigation menu after installation. So, understanding a little bit about the chaining workflow. Here you will see a portion of the code actually in Python, but we can move on and say over the next 5 sections you will execute the top 5. We will execute, not actually, but we will see how to execute partially the top 5 workflows that are most suitable for durable functions. So to achieve our end goal, we will use durable functions, okay? And the chaining workflow is the simplest way to utilize durable functions. Although it's possible to implement this workflow by solely using Azure Functions, as we mentioned before in queues. So for the chaining workflow, the durable functions exist to call several activity functions in a desired order to visualize the big picture of the entire workflow. The durable functions runtime manage the intermediate state, and all that is required from you is to define the workflow for the orchestrator and write the activity functions. Fan out, fan in workflow. Durable functions offer a fan out, fan in workflow, which involves running multiple functions simultaneously and then consolidating the outcomes. This method is efficient and useful for performing, as we said, parallel batch jobs like website backup, processing order, or computing a combined result. Here you can see also a portion of the Python code. Here also we have the monitor workflow. So as you can see, the monitor workflow again against monitor workflow via time trigger functions. So Azure timer trigger function has the ability to fix polling interval. Time trigger runs on a schedule, a risk of overlapping in long-running tasks, and error handling is difficult. What we can manage with durable functions with monitor workflow. Flexible polling interval, monitor runs on interval, monitor functions will not overlap, and relate different activities in workflow and handle errors. So let's see a little bit about human interaction workflows. In real-world scenarios, several automated processes entail human interaction. For example, when a website comment is submitted, a human moderator must approve it before being posted. The moderator can review the comment and either approve it, make it inaccessible on the website, or decline it, deleting the comment. If the moderator fails to act within the specified time limit, the comment escalates to a higher authority. Another example could be an organization that necessitates human approval for processes such as employee vacation or managerial approval for expenses exceeding a certain amount. Human interactions call for the approver's availability, and the workflow process must remain active for a specific duration and have a dependent mechanism when it times out, prompting actions such as escalation or cancellation. Engaging humans in automation use cases is challenging as they may not be as agile as accessible as cloud services. Using durable functions with timeouts and compensation logic within the workflow can empower such scenarios. The synchronous human interaction pattern can enable the durable function orchestrator to pause at a specific point in its life cycle, waiting for an external event, usually human action or decision making. If the interaction doesn't happen on time, the durable function can remind or handle the failure. This workflow can also be applied to any external process that takes time to finish and can keep the orchestrator in the loop about its completion via external events. So here we can present also some useful durable functions, the URLs. This is the GitHub, where you can have the Azure Functions durable extensions. You can see also the core tools, the Azure Functions, and actually you need also the Postman for the local development. So after that, I think that below we provide a set of, as we said, helpful, useful URLs. And here we have the Azure Durable Functions Q&A.
Costadina, let me thank you for this information-packed presentation. Thank you very much. Let's see if we have some questions from our audience then. Okay, I see one already. What were the time limits for execution in Azure functions and the duration constraints for durable functions? Costadina, this is the first question from our audience.
Okay, am I audible?
Yes, we can hear you fine.
Okay. So regarding the Azure Functions, we know already that the Azure Functions, if you call it with HTTP, you have a 5 minutes, no matter if you have a consumption plan. Maximum can be 10 minutes, but if you have a premium plan, because it depends on the plan also, you can have 30 minutes, maximum 60 minutes. A dedicated plan means unlimited. But honestly, there is a paragraph in the MSDN URL that mentions that no matter what kind of plan you utilize, for Azure Functions at least, you have 5 minutes. But the durable, this constraint, actually, we don't have it in the durable functions. You can have unlimited as long as the call is based on a starter, the HTTP starter. The HTTP trigger is the one that triggers actually the starter, and then the durable functions makes the rest of the job based on the durable function types, as we mentioned, orchestrator, and also we do have, besides the orchestrator, the activity functions that they do the actual job. So the durable functions, they don't have a limit.
Excellent. Sounds good. Thank you. Thank you very much, Costadina, for this. Let's see if we can have time for one more question from our audience. Yes, I see one more here. Is it possible to employ Azure Durable Functions for handling large-scale data? Let's try to answer this as quickly as we can, Costadina.
Yes, it's possible to employ to pretty much do that for large data. For instance, for ETL pipelines, durable functions can be used to orchestrate ETL pipelines that move data from source systems to data warehouse or data lakes. For data enrichment, durable functions can be used to enrich data with additional information from other sources. And for machine learning, durable functions can be used to orchestrate machine learning workflows that train and deploy machine learning models. So actually we can do that, but it's good to know that a replacement for a big data processing platform like we have the Azure Data Factory or Apache Spark, durable functions, it's not to make it as a replacement. It's better having durable functions for orchestrating workflows that involve big data processing, but it does not provide the same level, for instance, of scalability and performance as a dedicated big data processing platform.
Excellent, good stuff. Thank you very much, Costadina. So at this point, let me thank everyone for your active participation this afternoon. We will be sending a follow-up email for the recording of this event. Please do not forget to join our community. Moving on, don't hesitate to come back to us for any extra questions that may arise. As we are very interested in hearing your feedback, would be grateful if you could spend 5 minutes on this as well. So let's move to the next slides, please, the final one. Let me say that it's never too late to the next one. Let me say that it's never too late to register for our next event, This is already scheduled. It's entitled Azure Databricks Lakehouse, Ways to Load Data. You will see this in our next slide. And in this presentation, Michelle, who is a Microsoft MVP, will discuss the different ways to view and load data from external data sources, files, and Azure storage into Azure Databricks Lakehouse, as well as how to monitor and troubleshoot the data loads. For the time being, we wish you a very pleasant afternoon and warm wishes for the upcoming holiday season. Thank you everyone very much. See you in the next event.
Thank you so much also.